All right, part C says, use your work from part B to sketch on the same axis solutions that satisfy, and then they give me a number of initial values, 1, 2, 3, 4 of them. So I'm actually going to have 4 different graphs going on here. The first one satisfies the point where y of 0 is equal to 0. So I'm going to do this, I guess, in blue, just to... So y of 0 equals 0, that's going to be this point right here that I'm going to highlight in blue. And it's not going to be perfect, right? What do I know about y? I know that y is increasing from negative infinity to 4. So I can see that because these slope values get smaller and smaller, which means that the sketch of this graph, it's not going to be perfect, but the sketch of this graph is going to come up something like this, and the slope values are going to get smaller and smaller and smaller. Eventually I'm going to get to 4, and the slope value at 4 is going to be 0. All right, so there's my first graph of y of 0 equals 0. Then I'm going to go to y of 0 equals 2. This is another solution, right? Because differential equations can have infinitely many solutions based on that initial value. Once you give me an initial value, there's exactly one solution, but they gave me 4 different initial values. So this graph is going to kind of follow the same pattern. It's just going to slowly curve up until it gets to 4, and then when it gets to 4, it's going to have a slope of 0, something like that. And then y of 0 equals 4. Well, as soon as y of 0 equals 4, this graph just becomes a constant, right? So it's going to come this way. Everything's going to stay at 0 there. And then finally they say y of 0 equals 6. Well, I know as soon as I go above y equals 4, let's go back to our answer for part A, right? Y will start decreasing from 4 to infinity. So as soon as I go above 4, y of 0 equals 6, now this is going to start dipping down this way. And again, it's not going to be perfect. I'm just eyeballing this, but it's going to do something like that. So here are 4 different solutions to the differential equation dy dt.